Hello students, this is Mr. Reeves back with you again, and today we're going to be looking at solving systems of linear equations by graphing. I'm going to be making two videos. The first video is just going to be on solving systems given the two equations, and the second one is going to be solving problems by graphing. So I'm going to go ahead right now and dive right in to a couple of problems. This is from the textbook, page 231. I'm doing your turn. I'm going to do number 3 and number 4. So it says solve each system by graphing, check by substitution. All right, now I hope you notice right off the bat when you see these equations, they are written in slope-intercept form. Y equals mx plus b. Y equals mx plus b, where m is the slope and b is the y-intercept. Now, we did a lot of practice when we were still back in school, and since then, I've given you lots of practice on graphing in slope-intercept form. When you graph a line, you need at least 2 points. The y-intercept gives you one of those points. The y-intercept is actually 0b. For every y-intercept, x equals 0. So when I take a look at this first equation right here, I have the point 0, 2. Now I'm going to use blue for the second equation. When I take a look at the second equation, I have the point 0, negative 1. So if I want to graph this first line, I'm going to start at 0, 2. There's a point on that first line. And 0, negative 1, there's a point on the second line. But 1 point is not enough to graph a line. You need at least 2. It's always good to have more. And to get more points, that's where we use the slope. So right here in front of the x, that's going to give us the slope. Now, m should be a number. When all you see is a negative sign, that means we actually have a slope of negative 1. Now, slope, as hopefully you remember, we often refer to as rise over run, or oftentimes we will say it is the change in y over the change in x. So that's another way of looking at slope. So if I have the number negative 1, I'd actually like that to be a fraction, and you guys should know that to take any whole number and make it a fraction, you simply put it over 1. So that means my change in y is negative 1, so I'm going to go down 1, and my change in x is positive 1, so I'm going to go right 1. So from there, I'm going to go down 1 and right 1. I now have 2 points, but it's really a good idea to get more. And I could just keep doing this, down 1 and right 1, because the slope is the constant rate of change of a line. So I can go that way, or instead of going down and right, I can go up and left. And you can see I get a line here. Everywhere on that line are ordered pairs, are solutions that make that equation true. Let me try that again. Any point on this line, any ordered pair, any value of x and y is going to make that first equation true. All right, so let's take a look at the second equation. The second equation actually has a number right here, and that number is negative 4. But again, if I want to do the change in y over the change in x, it's a whole number, so I'm going to put it over 1. That means I'm going to go down 4, and I'm going to go right 1. So starting at the y-intercept, because that was the point they gave me, I'm going to go down 1, 2, 3, 4, and over 1. Now, if I were to try to do it again, 1, 2, 3, 4, I'd be off the grid. It'd be somewhere over here. So instead of going down and right, I can go up 1, 2, 3, 4, and back 1. Can I do it again? 1, 2, 3, 4, and back 1. Awesome. So I have 4 points that are on that line. I'm going to connect those. And again, any point on this line will make that second equation true. And as you can see, we have a point of intersection right here. That black point I just made is on both the red line and the blue line. Therefore, it makes both equations true. And that point is -1, 3. -1, 3. So the solution to this system is -1, 3. So we solved it by graphing. Now it says to check by substitution. Well, that -1 is x, and that 3 is y. So I have my first equation. I'm going to go ahead and make it in red because I made that my red equation. Y equals -x, or the opposite of x, plus 2. So I'm going to plug this in and see if it makes it true. So does 3 equal the opposite of, be careful, it's not the opposite of 1, it's the opposite of -1 plus 2. Well, what is the opposite of -1? Or a negative times a negative is a positive. Does 3 plus 1 equal 2? Yes. So that proves it makes the first equation true, but it has to make both equations true. So here we go. Now I'm going to go to my second equation. Y equals -4 times -1. Whoops, excuse me. We're going to start with y and x. Y equals -4x minus 1. Then I'm going to plug in, again, the same ordered pair. I'm going to put in 3 for y. I'm going to put in -1 for x. And hopefully you know that a -4 times a -1 is 4. 4 minus 1 is 3. 3 equals 3. So I just checked by substitution that ordered pair makes both equations true. So we just solved a system by graphing where both equations were in slope-intercept form, or y equals mx plus b. All right, so hopefully you can do those type of problems. Let's go ahead and look at the next example, which is also in slope-intercept form. Y equals -2x plus 5. So if we go right here, once again, we have our y-intercept. So I'm going to make this, again, my red equation. So b is equal to 5, or if we're to write it as an ordered pair, it's 0, 5. And my slope is -2, but I'm going to make it -2 over 1. So from there, I'm going to go down 2 and write 1. Down 2 and write 1. Down 2 and write 1. So again, change in y over change in x. Then I'm going to go ahead and connect those points. And everywhere on that red line makes that first equation true. All right, now I'm going to do this blue line, y equals 3x. Now you notice there's nothing here. I could write, if I wanted to, 3x plus 0. So my y-intercept is 0, or the ordered pair is 0, 0. So I hope some of you are thinking, hey, this is a proportional relationship. My slope is 3, or 3 over 1. Now again, they're both positive, so this time I'm going to go up and right. So from there, I'm going to go up 1, 2, 3, right 1, 1, 2, 3, right 1. And when I connect those points, I get a line. Again, any point on that blue line, not just the ones I made, but any point on that blue line makes that second equation true. And once again, we have a point of intersection. And that point of intersection is the point 1, 3. So what we're saying is 1, 3 is the solution to this system because it makes both equations true. So if I go right up here, again, I'm going to go to my first equation and call that my red equation. Y equals -2x plus 5. And I'm going to put in 3 for y because, again, this is my x and this is my y. I'm going to go ahead and put in 3 for my y. And I'm going to put in 1 for my x, and when I do that, I get 3 equals -2 plus 5. I get 3 equals 3, and it checks. So that proves that it makes the first equation true. My second equation, y equals 3x. Again, I'm going to put in 3 for y. I'm going to put in 1 for x, and I get 3 equals 3. it makes that one true as well. So we solved it by graphing and we solved it by substitution. All right, so those are equations that are in slope-intercept form. I was hoping to do one here in standard form. So I'm going to go ahead and flip over here to number 2. Again, I'm doing out of section 8.1. This is number 2 on page 234. So how do you graph it when it's in standard form? So again, hopefully you got some practice working on the problems that I assign on graphing in standard form. But just a quick reminder, one option is we could solve for y, and we could try to make these equations look like that equation. All right, but another option is to make a table. All right, remember, a line is just made up of ordered pairs. So I'm going to go to this first equation here. And again, I'm going to make this my red equation. So I'm going to make a red table. Now, you can pick anything you want for x or anything you want for y and match up the x and y that goes with it from the equation. But what we usually do is we put in 0 for x and we put in 0 for y, because 0 is the easiest number in math to work with. So if I take that equation, 2x plus y equals 4, and I go ahead and I put in 0 for x, I get 2 times 0 plus y equals 4. Well, what's 2 times 0? It's 0. That's gone, right? And I get y equals 4. So that shows me that 0, 4, when x is 0, here's the x-axis, right? When x is 0, y, here's the y-axis, y is 4. So 0, 4 is 1 point. Now, as you recall from just a few minutes ago, when we make a line, we need at least 2 points. So now instead of putting in 0 for x, I'm going to put in 0 for y. So I'm going to go back to my equation, 2x plus y equals 4. But this time I'm going to put in 0 for y. So I'm going to get 2x plus 0 equals 4. Well, that 0 just goes away. I get 2x equals 4. Dividing both sides by 2, I get x is 2. So that tells me that when y is 0, remember I put in 0 for y, x is 2. So when y is 0, here's the y-axis. When y is 0, x is 2. And that gives me 2 points on the line. Now again, it's nice to have more than 2 points. This method only gives you those 2 points. But I think we're going to be good because they're not super close together. So I want to make a line that goes through those 2 points. So again, every point on this red line makes this first red equation true. All right, I'm going to call this second one my blue equation like I've been doing. Again, this is in standard form. Standard form, by the way, I didn't write it. Standard form, let's see where I have some space. How about right here? Standard form is capital AX plus BY equals C. Whoops, capital AX plus BY equals C. Now, A, B, and C actually mean something, but we're not going to worry about it. We're just going to say this is a different form that's useful for different purposes. There's my X and Y, but notice it doesn't say Y equals MX plus B. All right, but what's great about standard form is it makes it easier to make these tables and to find the x and the y-intercept. So I'm going to write the equation right here, negative 3x plus 9y equals negative 6. And once again, I'm going to make a table to go with that equation. So I'm going to go up here and make my table. And again, you can have any points on a table, any points you want to. You can pick an x and find the y that goes with it, or pick a y and find the x that goes with it. We're going to pick 0 for x and 0 for y because they're the easiest to work with. So first thing I'm going to do is I'm going to put in 0 for x right here. So negative 3 times 0 plus 9y equals negative 6. Well, negative 3 times 0 is 0, so I get 9y equals negative 6. Now, if you're thinking, uh-oh, 9 doesn't go into 6, or negative 6, you're correct. But we can get that as a fraction. We're going to simplify. We're not going to make it a decimal. We get negative 6 divided by negative 9, and negative divided by negative is a positive, and 6 and 9 both are divisible by 3. So if I divide this one by 3 and I divide this one by 3, I get 2/3. So it's not as nice as an integer would be, but it's really not that bad when x is 0. So here's the x-axis. When x is 0, y is 2/3. We can't get it exactly, but I'm going to say it's about right there. Okay, so now again, I'm going to write my equation, negative 3x plus 9y equals negative 6. I'm just writing that second equation. But now instead of putting in 0 for x like I did here, I'm going to put in 0 for y. So negative 3x plus 9 times 0 equals negative 6. So this time this one goes away. And this is a nicer number because negative 6 is divisible by negative 3. When you take negative 6 and you divide it by negative 3, you get positive 2. So 2, 0. When x is 2, y is 0. Or when y is 0, here's my y-axis. When y is 0, x is 2. And what's nice about that is that actually is the solution as well. Again, it would be nice to have, it would be nice to have more than, man, everything's going crazy. It'd be nice to have more than 2 points. And if we wanted to work a little harder, we can get them. But since the point was to get the point of intersection and we got the point of intersection, we're good. So I'm going to do my best to make a line that goes through both points. Alrighty. And so our solution that we have here is the point x is 2 and y is 0. So the solution to this is 2, 0. Now the directions didn't say we had to check it by substitution, but good math students and good math teachers are going to go ahead and do that. So I'm going to check the first one. Again, x is 2 and y is 0. So I'm going to go up to that first equation. 2 times, and right here I'm going to put 2. 2 times 2 plus 0 is supposed to equal 4. Well, 2 times 2 is 4. Does 4 plus 0 equal 4? It does. So that proves it makes the first equation, or the red equation, true. Now let's try the blue equation. Again, negative 3 times x. So negative 3 times our x value is 2. Plus 9 times 0 is 0. So this goes away. Well, what's negative 3 times positive 2? It's negative 6 equals negative 6. It works. So we proved at this point 2, 0 makes both the first equation and the second equation true, which proves that it is the solution and our graph was correct. Well, I hope this was helpful, and I encourage you, if you are still struggling, to watch this video again or go back and watch the Khan Academy videos or the Dr. Berger videos. My next video for you is going to be solving some word problems by graphing. Thanks for watching, everybody.